Now we come to page 51 of our notes. So we have a frame here, and with nodes A and B, and determine the reaction at the supports and whether the frame is rigid. So, and of course, we determine the reaction at the supports, which are the supports are points A and B, and whether the frame is rigid, whether the frame is a rigid body. It means a rigid body. So, and of course, the first part of the question should have no problem to you, and you just apply fx equal to 0 and fy equal to 0. And but the problem is about this part, whether the frame is rigid. Okay. So, and let me discuss this. So a frame is not rigid if equilibrium means P has to be equal to 0. It means if P equal to 0, for example, the frame is not rigid if P not equal to 0 means, and summation fx or summation fy, let's say fy, does not equal to 0, or summation fx does not equal to 0, okay? Or summation m does not equal to 0. If P does not equal to 0 means any of these three, it means the frame is not rigid. The second thing is, if the frame is not rigid, if P is not equal to 0, either these 6 terms are infinite. It's okay. So the frame is not rigid if any of these problem exists. If P does not equal to 0 means any of this, or if P does not equal to 0 means any of these 6 is equal to infinity. Okay. Now we have so we go to the problem itself. How many rigid bodies do we have in this problem? How many rigid bodies do we have in this problem? Because the whole frame, we don't know whether it is rigid, but how many rigid bodies do we have? There's 1, 2, and remember we have these 2, 3, 4. We have 4 rigid bodies. And within these 4 rigid bodies, 2 are 2 force bodies. So for these 2 force bodies, what do we know about these 2 force bodies? That means for these 2 force bodies, their forces are always go along the go along the 2 points. So for these two and for these two, we don't need to draw the free body diagram. The free body diagrams. We only need to draw the forces, the tension of these forces. Let me put it. Let me put okay. Let me put it like C, D, and E and F. So this is TCD, TCD, and TEF and TEF. Okay. And this is one thing. The second thing is what type of support do we have at A and B? What is this kind of support? Pin or roller? Pin or roller support at A and B? Pin. Okay. So these are pin support. So we have AX and AY, BX and BY here, and in free body diagrams, we don't need this. We don't need to draw the support. We only need to draw forces. We only need forces. We don't need support here. Okay. We only need forces. We don't need support. Then these are the two free body diagrams in this problem. Now we consider we look at this. We look at the free body diagram on the left. We look at the free body diagram on the left. So summation MA equals 0. It means TEF minus 2AP equals 0. Because we take moment about point A, that we don't have moments for here, we don't have moments here, we don't have moments here because the moment arm equals 0. Right? We take moment about A. Summation MA equals 0 for this rigid body. So for these 1, 2, and 3 forces, we don't have moment arm. We don't have moment arm here. So the only two forces that have moment arm is A times TEF minus 2A times T. Right? So this TEF is equal to 2P. And this is from the left hand side, and from the right hand side we have MP. We take MP equal to 0. That means, and of course we don't count the moments here. We don't count this moment. We don't count this moment, and we don't count this moment. What do we have is ATEF is equal to minus 2AP is equal to 0. So the only solution here is actually to P equals to so let's have a look. And because for equilibrium we have these two, right? We have these two equal to 0. But let's look at the summation MP. If P that is not equal to 0, it means TEF is not equal to 0. It means summation MP cannot be 0. It's okay. 20 minutes. Very good. You can. Oh, sorry. I put the. I made the wrong figure. I think it should be. Oh, sorry. Why did I? Sorry. Sorry. Very good. Thank you. Thank you. Okay. And let me go smaller. And this calculation shows us if P is not equal to 0 for this structure. For this structure, if P is not equal to 0, MB cannot be 0. So you can go home and check. If P is not equal to 0, MB cannot be 0. Okay. So if P equal to 0, MB cannot be 0, it means it will go against, it will meet this one. So this structure is not a rigid body. Okay. And after you have finished marking this page, then we can go to before we end before the end of the class, we go to the next page. We go to page 52. So before the end of the class, I want to so this is a hydraulic lift table. Hydraulic means this one, and it has a platform and two languages, and so this is you can say this one. And so in this problem, so we look at what to determine here. What do we need to determine in this problem? We need to determine this one, the force exerted by each cylinder. Now, and before we end the lecture, and I've asked you to do something for me. And in this structure, in this frame or in this machine, and I want to know which are two force members and which are multi force members. multiple force members. So any of these members are two force members. Okay, how many members do we have here? We have let's look at from the left hand side. We have AD. We have this BDE. We have BC. We have CG, and we have this platform. And I would say I put, how did I put up? This, let's say this is point J. So we have A, C, B, D, E, B, C, and C, G, and A, B, J, C. So, and actually we have D extra. So which of them are two force members? Which of them are two force members? Two force members are members with external forces acting only at 2 points of the structure, at 2 points of the rigid body. So, two force member is a rigid body that has only 2 points with external forces. So, let's look at them one by one. Is AD a two force member? AD is this one. Is it a two force member? Because all the forces acting on AD goes to point D or point A. Okay, it goes either to point A or point D. There are no forces. There are no forces in the middle, right? There are no forces in the middle. So AD is a two force member. Now for BDE, external forces would act on points B, points D, and points E. So it is not a two force member. It is actually a three force member. Now for BC, and this force and half of W acts on here. This and BC are two different structures. These are different. BC and ABJC are different. BC and ABJC JC are different. So for member BC, that this half W does not act on BC. So all forces on BC act on either point B or point C. So it is a two force member. And how about CG? Is CG a two force member? It seems so. And ABJC is so for ABJC it is a platform that it has forces with at A, B, J, and C, and of course this is not. And for this CH, and if you've seen one of these in your life, that you know that all forces only act on here or here. right? If you if you've seen this, if you have seen this in your in real life, that you know forces only act here on here and here. So this one is true force body. So next Tuesday, I will go on to work on the how to analyze this problem, how to work on this problem. It's okay.